In this lecture, we are going to talk about limits of functions. What is a limit? A limit is defined as the value that a function approaches as it goes to a given x value. Now, in limit, we have the left hand side limit, the left hand side limit, and then we also have the right hand side. So now, what is the distinction between the left hand side limit and the right hand side limit? So for example, if we have limit maybe as x approaches a, then you normally see a plus sign here. It means limit, this is the right hand limit as f of x approaches L. Then this is a right hand sided limit. It is coming from the right hand side. Then the left hand side is limit as x approaches a from the left. So it is normally denoted with a minus on top of the specific limit as f of x approaches L. So now when do we say a limit doesn't occur? By the way, let's first understand the definition of a limit. When the limit of the function on the left equals the limit on the function of the right, and this value also equals the value of the function, then we say the limit of that function occur. So for example, let me write it here. So if the limit of x approaching a from the right hand side of fx is equal to the limit as x approaches a from the left hand side of fx, and then this is equal to f of a, then we say that this limit has occurred. But a limit does not occur when the limit as x approaches a from the left is not equal to the limit as x approaches a from the right. And also a limit does not occur if even in the case where x approaches a from the right hand side is equal to the limit as x approaches a from the left hand side, but is not equal to the limit of the function f of a, then we say a function does not occur in this case. So let's use the above graph as a case study. So now let's come to this graph. What is the limit as f of x? What is the limit? So limit of f of x as x approaches minus 1. What is it? So now remember what we said. We said that a limit is defined as the value that the function approaches as it goes to a given x value. So you see that as we approach minus 1, this is minus 1 from the left hand side, and you see that this limit approaches 0. The function approaches 0 because it is 0 here. And if as we approaches minus 1 from the right hand side, you see that still this function to approaches 0. So the limit at the as x approaches minus 1 from the left hand side and the right hand side all approaches the function, and that approaches 0, and therefore this is equal to 0. What about limit as x approaches 3 of f of x? What is this limit? You see that as f of x, this is 3. So what does the function approach at 3? You see that as f of x approaches, as x approaches 3, the function approaches this is a function, it approaches a value 2, and therefore limit as x approaches 3 of f of x is equal to 2. Now, what is the limit? Let me write it here. Of f of x as x approaches 5. What is the value of this limit? So you see, this is 5. So this is the value 5. So let's trace it. You see that as the function approaches 5, this as x approaches 5, you see that the function goes to 0. So you see that the function is decreasing till it gets to 0. And therefore the limit as x approaches 5 is equal to 0. So this is the concept of limit. The value that the function f of x approaches as x approaches a given value. So now with that in mind, let us come here. What is the limit as x approaches minus 3 for this particular graph? You see that as x approaches minus 3, at minus 3, there is a hole in the graph. This hole means that there is discontinuity, or there is a jump at that point. And therefore, you see that the limit as x approaches, okay, so let me write it here. The limit as x approaches minus 3 from the left is equal to the limit as x approaches minus 3 from the right, but it is not equal to the value of the function because there is a jump at that point. And for that reason, because of that hole in the function at that point, this limit does not exist. Now, what about limit as x approaches 2? So what is that limit? So you see that 2 is here, and again there is a jump, or there is a hole at x equal 2, and for that matter this limit does not also exist. Now what about x equals 4? This is 4. So you see that x equals 4, the function approaches 3. You see, so you see that limit, if we take the limit, if we approach it, we approach 4 from the left hand side, and if we approach 4 from the right hand side, everything is converging at this value, and that value is 3. So you see that limit as x approaches 4 exists, and the value of that is 3. Now what about limit as x approaches 6? Sorry, what about limit as x approaches 5? So you see that at 5, there is a discontinuity at 5, x equals 5. So this function at 5, at less than 5, it approaches 0, and at more than 5, it also starts from 0 and goes to infinity. So there is a jump at x equals 5, and therefore the function is discontinuous. So having understood the concept of limit, let us use that concept to solve the following questions. What is the limit as x approaches 0 of x cubed plus 4x squared minus 3? Now, if you see a limit of a polynomial, it is true. So it is limit as x approaches 0 of this polynomial. If you see a limit of a polynomial, then it is straightforward. You just have to substitute the value of x, the value that x is approaching, into the function and find the limit. So in this case, this is equal to Wherever you see x, you put 0 inside. So this is 0 cubed plus 4 times 0 squared minus 3. So this becomes 0 plus 0 is 0 minus 3. So this limit is minus 3. Now let us also find limit as x approaches 2 of 2x plus 5. So this one too, it is straightforward. This is a binomial. So wherever you see x in this function, you just put 2. So this is equal to, and whenever you are substituting the value, then you don't repeat the limit again. So this is just equal to 2 times 0 plus 5. Sorry, 2 times 2 because x approaches 2. So this is 2 times 2 plus 5. And that is equal to 4 plus 5. And 4 plus 5 is 9. So limit as x approaches 2 of this function is 9. What about limit as t approaches 6 of the function 8 times t minus 5 times t minus 7? So this one too is straightforward. You just put the value of t equals 6. So this is equal to 8 times t. T in this case is 6. 6 minus 5 in one bracket. Times 6 minus 7 in another bracket. So this is equal to 8 times 6 minus 5 is 1. Then 6 minus 7 is minus 1. Minus 1 times 8 is minus 8. And therefore, limit as t approaches 6, this function approaches minus 8. Now, having gotten that, then let's come to the limit of rational functions. So now, what is the limit as x approaches minus 3 of x cubed plus 4x plus 3 divided by x squared plus 5? For rational functions, in order to find the limit of rational functions, all you must ensure is that the denominator, when you put the value of x, the denominator does not go to 0. Because if the denominator of this function goes to 0, then it will make the whole function undefined, and therefore the limit would exist at infinity. So you must ensure that this denominator, when you put in this value, does not go to 0. So in this case, if we put in minus 3 squared is 9. 9 plus 5 is 14. So the denominator does not go to 0. And therefore, this is straightforward. You just have to insert minus 3 inside. So this is equal to minus 3 cubed plus 4 times minus 3 plus 3 divided by minus 3 squared plus 5. So minus 3 cubed is 27. Is minus 27. Then 4 times minus 3 is minus 12 plus 3 divided by minus 3 squared is 9 plus 5. So this is equal to 20 minus 12 plus 3 will give minus 9. So minus 27 minus 9 will give minus 36 divided by 9 plus 4 is 14. So you see that we can further simplify this. So we can simplify this further by dividing both the numerator and the denominator by 2. So this is equal to minus 36 divided by 2 is minus 18. Then 14 divided by 2 is 7. So this limit is minus 18 over 7. So what about limit as x approaches 2 of x plus 3 divided by x plus 6? So This one too is straightforward. If you put 2 here, it doesn't go to 0 because 2 plus 6 is 8. So therefore, this is equal to 2 plus 3 divided by 2 plus 6. 2 plus 3 is 5 and divided by 2 plus 6 is 8. So this limit is 5 over 8. Now let's look at the factoring method in rational functions, finding the limits of rational functions using the factoring method. So for example, let's find the limits as x approaches minus 3 of x squared minus 9 divided by x plus 3. So you see that as x approaches minus 3, if you put minus 3 in this equation, it will be minus 3 plus 3 is 0. So the denominator is 0. And that will make this limit undefined. And that will make this function undefined. And for that reason, we want to find a way of skipping that. So at this point, we cannot make the substitution. However, we know that this x minus 9 is the same as limit as x approaches minus 3. X squared minus the 9 can be written as 3 squared divided by x plus 3. And then this is the same as, this is equal to, okay, so let me write it down here. Limit as x approaches minus 3. This is difference of two squares. A squared minus b squared is equal to, in one bracket, a minus b. Then in another bracket, a plus b. So let's use this expansion to expand this. So this is equal to, in one bracket, x minus 3 times in another bracket, x plus 3 divided by x plus 3. So you see that using this expansion, we can then cancel out x plus 3 and x plus 3. So the limit is now limit as x approaches minus 3 of x plus 3. So at this point, if we put in the value of 3, the value of x, then this function still remains defined. So we can go ahead. So this becomes minus 3 plus 3, which is equal to, if we cancel out x plus 3 and x plus 3, here we'll be left with x minus 3. So here is minus 3 minus 3, and that is equal to minus 6. So this limit approaches minus 6 as x approaches minus 3. Let's also find the limit as 2x squared minus 7x minus 15 divided by x minus 5. So limit as x approaches 5. What will this approach? So now you see that if we put x equals, so let me write it well, as x approaches 5. See that if we put x equals 5 in this function, the denominator will go to 0, and that is what we want to avoid. So we must find a way of factoring the numerator so that we can avoid that situation where the denominator goes to 0. So now, since this is a quadratic equation, let's try and factorize the quadratic equation. So you see that 2 times minus 15 will give us minus 30. So we are looking for two numbers that when you multiply, you get minus 30. But when you add, you get minus 7. So those two numbers are minus 10 and 3. Minus 10 times 3 is minus 30. However, minus 10 plus 3 is minus 7. So this limit is equal to limit as x approaches 5, 2x squared minus 10x plus 3x minus 15 divided by x minus 5. And this is equal to limit as x approaches 5, we can factorize 2x from the side. So 2x into bracket x minus 5. Then we can factorize 3 from this side. So plus 3x minus 5 divided by x minus 5. So this is equal to limit as x approaches 5. So this becomes in one bracket 2x plus 3. Then this bracket is x minus 5 divided by x minus 5. So you see that this x minus 5 and this x minus 5 can cancel out. So at the end of the day, we are left with limit as x approaches 5 of 2x plus 3. So at this point, we can then go ahead and evaluate the limit. So this is equal to, we just put 5 inside. 2 times 5 plus 3. 2 times 5 is 10. 10 plus 3 is 13. So the limit, this limit is 13. At this point, let's talk about limits at infinity. So let's assume, what is the limit as x approaches infinity of 4 over x? So now, how do we find this limit? Let's assume that x is equal to 4. You see that if we put 4 in this, it becomes 4 divided by 4. And 4 divided by 4 is equal to f of x. So f of x is equal to 1 in that situation. Now, what about if x is equal to 8? What is f of x? So we just put 8 here. 4 divided by 8 is 1 over 2, which is 0.5. What if x is equal to 16? F of x is just going to be 4 divided by 16. And 4 divided by 16 is 1 over 4, which is equal to 0.25. What if you make x as big as 1000? If we put 1000 here, f of x will be approaching 0.004. So you see that as the value of the denominator become exceedingly large, the values of f of x is approaching 0. And therefore, limit as x approaches infinity of 4 over x is equal to 0. So for any limit for which the denominator becomes exceedingly large, approaching infinity, then the function f of x approaches 0, either from the left hand side or from the right hand side. So now, what is the limit? So let's do this example. Limit as x approaches infinity of 5x cubed minus 2x squared plus 7x minus 13 divided by 12 minus 2x plus x exponent 4. What is the limit as x approaches infinity of this? Now, if we find, in finding the limit of rational functions, the most important term in each side, whether the numerator or the denominator, is the term with the highest degree of x. So you see that in this case, the highest degree in this polynomial is x exponent 3. And in this case, the highest degree is x exponent 4. So we need to just ignore the rest and just find. So this will be equal to limit as x approaches infinity of 5x cubed over x exponent 4. So this is equal to, so you see that x exponent 3 will divide x exponent 4. So it will be left with limit as x approaches infinity of 5 over x. Because this x exponent 4 can also be written as, let me write it here, x exponent 3 divided by x exponent 3 times x. So that this x exponent 3 can cancel out. So that we'll be left with 1 over x. 5 times 1 over x is 5 over x. But remember what we said earlier. Limit as x approaches infinity. As the denominator becomes exceedingly large, f of x approaches 0. So this limit is equal to 0. Now, let's also find limit. So let me write it here. Limit as x approaches infinity from the right hand side of 3x cubed minus 2x squared plus x minus 4 divided by 4 plus 2x minus 5x cubed. So remember what we said earlier on. If it is limit at infinity, then what matters about the rational function is the term with the highest degree. So you see that for the numerator, the term with the highest degree is what? 3x cubed. And for the denominator, the term with the highest degree is also 5x cubed. And therefore, this is just equal to limit as x approaches infinity from the right hand side of 3x cubed divided by 5x cubed. So x cubed and x cubed will cancel out. So this is equal to limit as x approaches infinity from the right hand side of 3 over 5. Anytime you find this, limit as x approaches any value of a constant, the answer is that constant. So this is equal to 3 over 5. I made a mistake. There is a negative sign here, and therefore this will be equal to minus 3 over 5. So the final answer is minus 3 over 5, because here was minus 5x cubed. So let's solve limit as x approaches infinity of 2x cubed minus 2x plus 5 divided by 3x cubed plus x squared minus 5x plus 13. So it's the same thing. For limits at infinity, the most important thing is the highest degree terms. So you see that for the numerator, this is the one with the highest degree. And for the denominator, this one is also the highest, the term with the highest degree. And for that reason, this limit is limit as x approaches infinity of 2x cubed over 13x cubed. So this x cubed and x cubed can cancel. So it is equal to limit as x approaches infinity of 2 over 13. Remember that limit as x approaches any value of a constant is equal to that constant. So this is 2 over 13. Now, let's also find this limit as x approaches infinity from the right hand side of 2 exponent x divided by x squared. So what is the answer for this? So in this case, let's try substituting the limit into this equation. So this will become equal to So now let's try and put the limit. It will be 2 exponent minus infinity divided by infinity squared. What does this mean? You will see that 2 exponent minus x is equal to 1 over 2 exponent x. So it's 1 over 2 exponent x. And therefore, 2 exponent minus infinity is equal to 1 divided by 2 exponent infinity times infinity squared. What does this mean? 2 exponent, a very big number, will give us a very, very big number. A very big number squared will also give us a very big number. A certain very big number times another very big number will give us a very, very, very big number. And therefore, this is equal to 1 over a very big number, infinity. And remember what we said, as x approaches infinity, either from the left or from the right, the function approaches 0. So this function is 0. Now, let's also find limits as x approaches infinity from the right hand side of 3 minus 3x cubed plus 2x squared minus 4x plus 5. So this is equal to, remember what we said? We said that for a polynomial, the most important thing when it comes to limit at infinity, so far as you see limit at infinity, you must consider the term with the highest degree. So this is equal to limit as x approaches infinity from the right hand side of, this becomes minus 3x cubed. So let's then substitute the limit. It is equal to limit as x. Okay, so let's substitute the limit. Anytime you are substituting the limit, then you don't have to repeat the definition limit as x approaches our value. So this is equal to minus 3 times minus infinity cubed. So now, what is the answer? You see that a number minus x cubed is equal to minus x. So therefore, minus infinity cubed. So this is minus 3 times minus infinity cubed is times minus infinity cubed. So minus 1 times minus 3 times minus. In other words, minus times minus will give us a positive value. So this will be, so we have a certain constant times a very, very big number. We are going to get a very, very, very big number. And therefore, this will give us infinity. So let's come to limits that involves the conjugate method. For example, what is the limit as x approaches 5 of square root of x plus 11 over minus 4 all over x minus 5? So you see that if you put x equals 5 in this function, it will make the denominator 0, and that will make this function undefined. So what we need to do is to rationalize. So in this case, this is equal to limit as x approaches 5 of square root of x plus 11 minus 4 over x minus 5. So in rationalizing, you multiply both the numerator and denominator by the conjugate of either the numerator or the denominator. So in this case, it is the numerator. So this becomes times square root of x plus 11. Then instead of minus 4, this becomes plus 4 divided by square root of x plus 11 plus 4. So this is equal to limit as x approaches 5. So let's distribute this. So this becomes square root of x plus 11 times square root of x plus 11 plus 4. I'm distributing all of this to this. Then minus 4 times square root of x plus 11 plus 4. All divided by x minus 5 times square root of x plus 11 plus 4. So this is equal to, now what is square root of 11 times square root of 11? It's just x plus 11. Remember, root a times root a is equal to a. And therefore this is limit as x approaches 5 of, this becomes x plus 11. X plus 11. Then square root of 4 times root of x plus 11 becomes plus 4 root x plus 11. Then this one will become minus 4 times root x plus 11 becomes minus 4 root x plus 11. Then minus 4 times plus 4 becomes minus 16 divided by x minus 5 in one bracket times root of x plus 11 plus 4. So this is equal to limit as, so this was approaches, as x approaches 5. Now you see that this and this can cancel out. So we are only going to be left with x plus 11 minus 16. So what is 11 minus 16? It is minus 5. 11 minus 16 is minus 5. So this one is x minus 5 divided by x minus 5 in one bracket times root x plus 11 plus 4. So let me continue from this side. So you see that this x minus 5 and x minus 5 cancels. So the limit just becomes limit as x approaches 5 of 1 over square root of x plus 11 plus 4. So you see that at this point, if we put in 5, we will no more get any problem. So let's just do the substitution. It becomes root of, so x plus 11 is 5 plus 11 and plus 4. So this is equal to 1 over square root of 5 plus 11 is 16. Root 16 is 4 plus 4. And this is equal to 1 over 8. And therefore, this limit as x approaches 5 of root of x plus 11 minus 4 over x minus 5 equals 1 over 8. So let us find limit as x approaches minus 2 of x plus 2 divided by square root of x plus 6 minus 2. So you see that if we put minus 2 in this equation for the denominator, it's going to be minus 2 plus 6. And minus 2 plus 6 is 4. Square root of 4 is 2. 2 minus 2 is 0. So if the denominator becomes 0, it will make the function undefined. So we need to find a way of escaping that. And the way to do that is by rationalizing. So this is equal to limit as x approaches minus 2 of x plus 2 divided by square root of x plus 6 minus 2, and multiply both the numerator and the denominator by the conjugate. So it becomes x plus 6. Instead of minus 2, this becomes plus 2 divided by square root of x plus 6 plus 2. So this is equal to limit as x approaches minus 2 of x plus 2, then times all of this, which is square root of x plus 6 plus 2, then divided by, this becomes square root of x plus 6 minus 2 in one bracket times square root of x plus 6 plus 2 in another bracket. Now remember that a minus b in one bracket times a plus b in another bracket equals a squared minus b squared. And this is difference of two squares. So this denominator is difference of two squares. So this is equal to limit as x approaches minus 2 of x plus 2. Then in another bracket, x plus 6 plus 2 divided by, so this becomes square root of x plus 6 squared minus 2 squared. So let me continue from this side. So this is equal to limit as x approaches minus 2. And we have x plus 2 in one bracket times square root of x plus 6 in another bracket plus 2, all divided by square root of x plus 6 is x plus 6, then minus 2 squared will become minus 4. So this is equal to limit as x approaches minus 2, then x plus 2 in one bracket, then square root of x plus 6 plus 2 divided by x plus 6 minus 4. So it's just going to be x plus 6 minus 4. And 6 minus 4 is 2, so the denominator is x plus 2. So now this x plus 2 and x plus 2 can cancel out. So we are left with limit as x approaches minus 2 of square root of x plus 6 plus 2. So this is equal to, and we just put the minus 2 inside. So that will give us square root of minus 2 plus 6 plus 2. And that is equal to minus 2 plus 6 is 4, root 4. So this is root 4 plus 2. And root 4 is 2, so 2 plus 2. And that is equal to 4. So let us find the limit as x approaches minus 1 of the function square root of x plus 10 minus 3, all divided by x plus 1. So you see that in this case, if you put minus 1 here, you are going to get the denominator as 0. And therefore, we need to rationalize. So this is equal to limit as x approaches minus 1 of square root of x plus 10 minus 3 divided by x plus 1. Then times square root of x plus 10, instead of plus 3, minus 3 becomes plus 3 divided by square root of x plus 10 plus 3. So that this is equal to limit as x approaches minus 1. So this becomes, in one bracket, square root of x plus 10 minus 3 times square root of x plus 10 plus 3 divided by x plus 1 times square root of x plus 10 plus 3. So that this is equal to, remember, difference of two squares. So this is limit as x approaches minus 1 square root of x plus 10 squared, then minus, remember, a minus b times a plus b equals a squared minus b squared, so minus 3 squared divided by x plus 1, then times square root of x So this is x plus 10 plus 3. So this is equal to limit as x approaches minus 1. Root x plus 10 is x plus 10 minus 3 squared, that is 9, divided by x plus 1 times, in another bracket, square root of x plus 10 plus 3. So let me continue from this side. So this is equal to limit as x approaches minus 1. X 10 minus 9 is 1, so it becomes x plus 1 divided by x plus 1 times square root of x plus 10 plus 3. So this is equal to limit as, so this x plus 1 and x plus 1 can cancel out. So limit as x approaches minus 1 of 1 over square root of x plus 10 plus 3. So at this point, we can then put in the value of minus 1, the value of x, which is minus 1. So this is equal to 1 over square root of minus 1 plus 10 plus 3. 10 minus 1 is 9, so it becomes 1 over root 9 plus 3, which is equal to 1 over 3 plus 3. And that is equal to 3 plus 3 is 6, 1 over 6. Two functions g is defined on a set of real numbers by g is such that x maps onto 3x minus 1 divided by x minus 2, where x is not equal to 2. I express g of x in the form g of x equals a plus b over x minus 2, where x is not equal to 2, and where a and b are constant. And then I hence find the limit of g of x as x approaches infinity. So you see that in the first part, they want us to express this function in partial fractions. So the function is 3x minus 1 divided by x minus 2. So in partial fractions, since the highest power here, the degree here is 1 and the degree here is 1, it will be equivalent to a certain constant, let's say a plus b over x minus 2, according to partial fractions. So let's find the LCM. It's just going to be x minus 2, so that this is a over 1. X minus 2 divided by 1 is x minus 2 times a, so this becomes a times x minus 2 plus x minus 2 divided by x minus 2 is 1, so plus b times 1, which is b. And all of this is equivalent to 3x minus 1 divided by x minus 2. So since they have the same denominators, then we can equate their numerators. So we have a times x minus 2 plus b is equal to 3x minus 1. So let's expand. This becomes ax minus 2a plus b equals 3x minus 1. So we can then group like terms. You see that the coefficient of x here is a and the coefficient of x here is 3. So this implies that a is equal to 3. Now, having found the value of a, you see that this has got no x, this one too. So minus 2a plus b is equal to minus 1. But we know the value of a is 3, so we can minus 2 times 3 plus b is equal to minus 1. So minus 6 plus b is equal to minus 1. So b is equal to minus 1, then we take minus 6 here, becomes plus 6. And therefore b is equal to 5. Remember that we got the value of a as a equals 3 and the value of b as b equals 5. So remember that it was g of x, and then g of x is equal to 3x minus 1 divided by x minus 2. And according to the question, we're supposed to express it in the form a plus b over x minus 2. And we got a as, so this is equal to, we got a as 3, so 3 plus b, 5 over x minus 2. So this is the first part of the question. So this is g of x. And then the second part of the question is saying we should find the limit of g of x as x approaches infinity. So II, which is limit as x approaches infinity of g of x. So let me write it here. This is equal to limit as x approaches infinity. G of x is this, which is 3 plus 5 over x minus 2. Now, by the properties of limits, you can then split this limit into two. Let me write it here. Limit as x approaches infinity of a certain function a of x plus another function b of x is equal to limit as x approaches infinity of the first function, which is a of x, then plus limit as x approaches infinity of the second function, which is b of x. This is a property of limit, and therefore this can be split into limit as x approaches infinity of 3 plus limit as x approaches infinity of 5 over x minus 2. Now, remember what we said. We said that limit as x approaches infinity of a certain constant function is that constant. So this is equal to 3 plus. Now, let's substitute this. 5 over infinity minus 2. So this is equal to 3 plus a certain big number minus 2 will give us another big number. And remember what we said, 1 over infinity. As the value of the denominator becomes extremely large, the function approaches 0. So all of this is equal to 0. So 3 plus 0. This is equal to 3. Evaluate limit as x approaches infinity of 3x over x plus 2. So remember what we said, limit at infinity. For limit at infinity, the most important thing is the highest degree of the numerator divided by the highest degree of the denominator. So this is equal to limit as x approaches infinity. For the numerator, the highest degree is 3x. And then the denominator, the highest degree is x. This is equal to, this x and x can cancel out. So limit as x approaches infinity of 3. And limit as x approaches infinity of a constant is that constant. And so this is equal to 3. So this is the A part of the question. Now, for the B part is saying we should find limit as x approaches 1 of x cubed minus 1 divided by x minus 1. So you see that in this case, if we put x equals 1 here, the denominator will be 0, and we want to avoid that situation. So what we need to do is to factorize the numerator. But here is x cubed. Now, there is a certain formula for doing that. If you have a cubed minus b cubed, it is equal to a in one bracket, a minus b, then times a squared plus ab plus b squared. So in this case, our a is x and then our b is 1. So we want to factorize this. We want to factorize s cubed minus 1. This is equal to our a is x, so x. Then our b is 1 minus 1 times our a is x, so x squared. Our b is 1 and our a is x. X times 1 is x, so plus x plus our b squared. And then b is 1, so 1 squared is 1. And therefore, x cubed minus 1 is equal to this. You can expand it. You still get back x cubed minus 1. Let's try and see. So x times x squared will give us x cubed. X times x plus x squared. Then x times 1 give us plus x. Minus 1 times x squared is minus x squared. Minus 1 times x is minus x. Minus 1 times 1 is minus 1. So you see that this x squared and x squared can cancel. This x and x can cancel, so it becomes x cubed minus 1. And therefore, this our expansion is right. So therefore, this limit becomes equal to limit as x approaches 1 of this x cubed minus 1. We'll replace it by this, which is x minus 1 times x squared plus x plus 1, all divided by x minus 1, so that this and this can cancel out. So we are now left with limit as x approaches 1 of x squared plus x plus 1. So we can do our substitution here. So we take 1 and dump it in the equation. We get 1 squared plus 1 plus 1. So this is equal to, and this is equal to 1 plus 1 plus 1 is 3.